Okay, so here I have my normal approximation along with the simulation. So I finished up all this stuff, and I have these pictures. Now what I want to do is just turn this into using the normal approximation to do what we did with the simulation and create a nice graphic. And so here's sheet 3. I can copy this sheet. That's probably the best thing to do. Copy it. Now I've actually done this once, but we'll do it again. New name. I have this, I'll call it ssAABNormal this time, so pretty much what I had before. And let's see, move it to the end, say OK. Okay, so there I have that same thing. Well, I don't need this plot, so I'm just going to get rid of it. I don't need that plot, so I'm just going to get rid of it. And so I'm gonna keep this one. Get it a little wider there. So this is the normal approximation, and I'll just leave all that. I don't need this stuff here anymore, and so I can get rid of that. I don't know what that is down there, so I can get rid of that. Okay, so I have my normal approximation. I didn't have to do anything new for that. And now what I'd like to do though is make that nice graphic with the alpha, right? So here's our p-value. So here's my p-value. I'm going to write it this way, and again what we needed were a bunch of zeros like that, and I'll highlight a couple of them, bring them down, and I need to go down here to, I think it was the 22, and then after that again I just want these values here. So I'll just say equals and click on that one for my F28, I guess, and I have those. Okay, and there's my p-value, and so what I'm going to do is only plot the normal approximation up to here, and then plot all of the p-value. And then we didn't do this on the simulation because numbers changed. Every time you recalculated, the numbers in here would change a little bit, not greatly, but a tiny bit. And here they aren't going to change because it's the normal approximation. It's a normal distribution, and it always looks like this. And so what we can add here is I would like to add a graphic for our alpha, our 0.05%. So I'm going to call it alpha rejection region. And what I want to do here is, much like I did with the p-value, I just want to have a bunch of zeros in the beginning, like this. We can center that in a minute. Now, the thing is, I don't know how far they come down. They might only come to here, they might go to there, and so forth. And so what I need to do is try to determine, how much, and so what I'm going to do is in here, I know the middle here is at 20, so I know I'm good there. That's 50% should be from the 20 on out, I'm just going to call this a reverse sum. And what I'm going to do here is I'm going to start summing. I want to sum from here down, okay, or from here down. And I just want to get those sums so that I can see when we hit 5% out here. And so I can just say equals sum. We've seen the sum command. And what I want to do is sum up from whatever place I'm in of these probabilities here under the normal distribution. Okay, so there, but I also want to go to the bottom. Now, if I just do this without dollar signs, what's going to happen when I copy this up, it's just going to sum up this number and just sum up that number. And just to kind of show you what happens here, notice, you know, that number's the same as that. I can make this a little bigger. Right, those are the same number, and if I grab this and pull it up to fill in, I'm just getting the same number. So it's not really summing, because if you look at this, it's just the sum of D28 to D28. So what I have to do is I have to have dollar sign at least on that 38. By putting that dollar sign there, that second D38 will never change, and the D could if I copied over to the right or left, but the 38 can't. And so now when I do that and pull up, you see they change, and here I'm at what, 3.75%, and then there I'm above 5%, I'm at 7.7%. And so my alpha region goes from 25 down to 33. And so that's what I want to do in here, is create an alpha region. And the way I'm going to do that is I played with it a little bit. We're just going to put in from here down a height. You know, we're just going to kind of color this in, and we'll just choose a height that's you know, maybe as tall as this. So maybe I'll go up to 140. And so this is just to get the right visual effect. And so I'm starting there. I'll do a Control C to copy and Control V, and I get my 140s. Here I need to bring my zeros down, and again this would be probably a little easier to read if I had it all centered so I can see it better. So center. Okay, and what I want to do is have all three of these plotted here. And now you could start over. If you started over, right, you could highlight these three, go down here like that, and then you could insert a bar chart, so column chart to them, and I can finish, and you know, notice what it looks like. You know, I need to make the histograms again. I need to fill things in and all that. I could do it. You know, I need to move my legend. You know, so first of all, oops, cancel that. There. I just want to move the legend over. You know, maybe I want to put it there. You know, so that looks a little better, so I can see what's what. Don't like that p-value on a line. Okay, so you know, I have that. I need to add my axes, titles, and so forth. Again, you know, here I need to come in here and format the data series. you know, so if I can change colors and that sort of thing if I want, but again, I need to take my spacing down to 0, but then I need my overlap up to 100%. Okay, so I needed both of those, so I say okay, and there I've got that. Now, notice the alpha rejection region is over top of the right hand side here, so I can't really see it. I've got a couple options. One option, since I need to go in here to data ranges and so forth anyway, one option is that while I'm in the data ranges, so now of course I need to add my categories because again I was starting at 1 instead of 0. So let me come over here and find my categories, 33 up to 0. Okay, so my categories are fixed now, so that's good. But one thing I could do is I could simply change this order like that, and you can see it over here that put it behind, and so that will do it. You know, so I just do it like that. Another way I could do it though is if I put them back like this. Okay, so I'll say okay. Is that I can usually with these things you can do some sort of transparency work, and again I'll go into the format data series. Here's transparency. Whoops. Oh yeah, I'm on the right one. See how it's highlighted in the right color here. I can go with transparency, and it's not showing up to me yet. But I could just make it transparent, maybe 50%. I can try that. I say okay. And there, now you see, I can see that, you know, there's that rejection region. So if my p-value had been out here somewhere, we would have rejected. But since it wasn't, since we were over here, since some of the p-value region was outside of the rejection region, I failed to reject, right? This has to all be inside there. And so I can go ahead and you know, toss in my titles and so forth and do this. And you know, so let's see, titles, you know, so I insert titles now, and I'm not going to bother doing this right now. I'm going to go back to this other page, but you know, I've got a subtitle here, and actually what I did was I put my title in and my x-axis and y-axis, and then I for my subtitle I said something about failed to reject the null hypothesis, and we can see that with this rejection region. Okay, so you know, there you know, this was pretty quick. I mean, I came up with the data that I needed, that normal approximation. I went over here to the 23. Oops, to the 23, and that was where I needed to add up my values, and actually, let's see, I'm gonna move this up a little bit because you know, I never actually found my p-value here, right? There's my p-value, because see, that's where I stopped at the 23. So my p-value is 0.14, which is about what we got with the simulation. I think that was back on sheet 1. Right, there's sheet 1, and where's my p-value? Yeah, p-value here was 0.151 this particular time. Again, every time I do things it changes. Here my p-value is 0.142, so pretty much the same. Definitely failed to reject, that's bigger than 5%, but now I can visually see it because this region starts where I would begin rejecting. And I kind of would have liked to do it with just a line and maybe an arrow, but this worked. And if I come back over here, I had done all that, and here I highlighted my values, so that was a little different. And here I used a gray instead of the yellow because I could always change those colors, but did that same bit. And I put over here, this is the subtitle, so if we edit this, you can, if I go to the titles, I put a fail to reject in for the subtitle and then just moved it over here to look a little better. But there you go. That is using this normal approximation, much like we used the simulation. But I didn't have to do those 33,000 cases. I just went through and did these 34 things here. 0 to 33, and created a nice plot, and so that's all we need to do this using the normal distribution. And actually, what we'll see in later chapters is it's even easier yet. But I want us to get this idea of what's going on. We're using the normal distribution to produce this sampling distribution. Okay, so that looks pretty much like this did. All right. Again, we ended up using a histogram versus a bar chart, and because these are discrete, but when we use the normal distribution, we have a histogram, and so that's different, but it's still the same basic shape and all that. So we just use that to generate that distribution, and we look to see whether our data which came in at the 23, that region, the p-value region, we look at our data in more extreme here. So there's the p-value region. Was that all inside this rejection region? And no, it wasn't. That's showing us that the p-value was actually bigger than our 0.05. Now, the one downfall to this region is certainly the area under all that gray is much bigger than 0.05. But if you look at where the gray overlaps with the red, this stuff, then that is where we're getting close to 0.05. It's actually 0.0375 here, but that's it. There you go.